In this video, we are going to do the 2008 slope field FRQ. So, the question is, it gives you the slope dy over dx equals y minus 1 over x squared, where x can't equal 0. On the x-axis, sketch a slope field for the given differential for the 9 points. So you can't have a slope over here, so you're going to have domain issues, right? So we're going to do some of these. So if you have, let's say, arbitrarily you pick 1, 0. This is x. This is y. So what's our slope? If we plug this in, we're going to get negative 1 over negative over 1, which is going to be a negative 1 slope. So you're going to go down here and you're going to have a negative 1 slope. Make sure the steepness looks correct. We're going to do one more of these and then we're going to pause the video and fill in the rest. So if you have 1, 1, the slope would be 1 minus 1, which is 0, over 1, which is 0. So usually what they do is they give you a point for all the 0 slopes and then all the other ones are not 0. So I'm now going to pause this video and fill in the rest. Okay, so for part B of this question, it says find the particular equation y equals f of x to differential equation with the initial condition f of 2 equals 0. So that's the point, 2, 0. We're going to need to do that. So usually you get a point by just separating the variables. Okay, so we have dy over y minus 1 equals dx over x squared. Now when you do this, this is the same thing as y minus 1 raised to the negative 1 power equals x to the negative 2 dx. Now we're going to integrate both sides. Now when you add 1, you're going to get 0 to the power. So it has to be an ln. So you're going to get ln of y minus 1 equals, you're going to add 1, so you're going to get x to the negative 1 divided by negative 1 plus c. Now, usually it's a good idea to take this point and plug it in right now. So now you're going to get ln of 2 minus 1, which equals, this is the same thing as negative 1 over x plus c. I'm sorry. The 2 doesn't go in there. The 0 the 0 goes in here. My mistake. So this should be a 0. And the 2 goes over here. So when you do this, you're going to get the ln of the absolute value of 0 minus 1 is 1 equals negative 1/2 plus c. So c has to equal 1/2. Now we're going to rewrite our equation. So now we have ln of y minus 1 equals 1 over x, well, negative 1 over x, plus 1/2. Now, in order to get y by itself, we have to e both sides. So when you e both sides, you're going to get y minus 1, absolute values, equals e to the negative 1 over x, plus 1/2. So now, you could actually separate these variables, and now you could say y minus 1 equals e to the negative 1 over x times e to the 1/2. So that's really your a, right? Or that's what I like to call is a. So now we could write our equation. So it's going to be y equals, you could always figure out e to the 1/2, but this is a non-calculator question. So I guess you could kind of leave it like that. So you could write e to the 1/2 times e to the negative 1 over x plus 1. That will be your equation. Now, you also have to specify the domain. Now, if you look at this particular graph, you have an issue with domain over here. And the point that they gave you, 2, 0, happens to be here. So you have to specify, this is where you have domain issues, so it's going to be x is greater than 0. That's an important, that's a must. Okay, please give me a second while I clear the canvas so we could do part C. We found the equation. Let me write that down. Y equals e to the 1/2 times e to the negative 1x plus 1 for x is greater than 0. So over here it says for the particular solution y equals f of x described in part B, find the limit as x approaches infinity. So now we're going to write limit as x approaches infinity equals, well, I could write this as e to the 1/2 plus negative 1 over x plus 1. So now I could plug in the infinity limit as x approaches infinity, and I don't need this equals right there. So e to the 1/2 plus negative 1 over infinity plus 1. So now we get the limit as x approaches infinity, e to the 1/2 plus negative 1 divided by infinity is negative 1 over 0, so negative 1 over infinity, is just 0, so you could write this. So that's good enough, or sometimes, if you really want to, anything to the 1/2 power means the root of it. So I hope this video helped.